Hello and welcome to the video lessons on teaching, learning and applying number and algebra. So we're going to begin our lesson with Unit 5. We want to look at algebraic expressions, equations and inequalities. What's the difference between these three terms? If I have x plus 2, it's an expression. In as much as you don't see any equal sign or any inequality symbol, it's an expression. But what if I have x plus 2 equal sign? Just because of the equal sign, it's an equation. Well, what if I have x plus 2 less than 4? Now, because of this symbol, anytime you see either less than, greater than, less than or equal to, and greater than or equal to, in any mathematical statement, then it's an inequality, because these ones are what we call the inequality symbol. So this is an expression, equation, and an inequality. Thank you guys for taking your time to watch this video. What is an algebraic expression? Expression with variables, numbers, and operations are called algebraic expression. Just as we mentioned, x plus 2, 3y, t minus 4 is an expression. Any algebraic expression contains a variable. The variables are the unknown, like a t, an x, or a y. Any letter is what? A variable. The fixed or the constants are the fixed numbers. If I see just like a 5 in any of those are the constants, right? So let's quickly move on to how do I formulate an algebraic expression. If I have words and I want to convert them into math expression, how do I do that? We have example. We say 5 more than a number. I don't know the number. So you can represent it with any variable like x. We say 5 more. So it's going to be x plus what? 5. So it could be y. You want to use y. It could be y plus 5. It could be x plus 5. We say, supposing it was 7 more, it will have been y plus 7. If it's 8 more, it's going to be x or y or k plus the 8. Let's look at the second example. It says 4 times a number, right? The times represent multiplication. So 4 times a number, say y, is subtracted, that's minus, we're looking at subtraction, from 3. So the number that comes right after the word from, write it first. To make it easy for you, 3, we say subtracted, minus 4 times a number y, that's 4y. And here we say the result, and the result, the whole of this is multiplied. So put that in parentheses. We say the result is multiplied by 7. So 7 parentheses 3 minus 4y, and you're done. Let's look at the third example. It says S scored 13 marks more than A2. We don't know A2 score, so we can represent it by any variable. We can say A2 will be equal to, say, an x. Therefore, AC score is going to be equal to what? We say AC score is 13 more than A2. So if this is A2 and we want 13 more, it's going to be plus 13. And you're done. All right, so let's move on to the next example. It says operations on expressions, right? We want to look at addition, subtraction, multiplication, and division. So first of all, it says simplify the following algebraic expressions. Let's look at the first example. It says 2 over x plus 3 over x plus 1. Just as if I have 1 over 2 plus 1 over 3, right? How do I go about this? The first thing to do is to find what? LCM, right? And to find the LCM, I just got to multiply the two denominators. So I'm going to multiply 2 multiplied by 3. It's going to give me 6, right? So when I come here, I just say, okay, since this is the product of the two, when I multiply my least common multiple, I'm going to say how many times can 2 divide 6, right? How many times can 2 divide 6? It's going to be what? 3. So now I'm going to say the numerator, which is 1 multiplied by the 3. So I have 1 multiplied by the 3 plus, we have to do the other side too. Now we ask ourselves, how many times can 3 also divide 6? You realize that 3 divided by 6 is going to be 2. So it's going to be with the numerator, which is 1 multiplied by whatever we have. It's going to be 1 multiplied by 2. Right. So we're going to use the same idea over here. Right. So the first thing I have to do is to find what? My LCM. So here, to find the LCM, we just have to multiply the two denominators. So now I have x plus 3 multiplied by x plus 1. Right? After that, I have to now divide it to find, we now have to divide the whole of it by each of the two denominators. So I have x plus 3 parenthesis x plus 1. And I want to divide by the first denominator, right? So here, I'm dividing by x plus 3, right? I'm dividing by this denominator here, right? So the whole of this divided by x plus 3, then x plus 3 is going to cross out x plus 3, and we are left with just x plus 1. So now we're going to multiply this x plus 1 by the 2, the first 2, that was the first numerator. So now I'm going to have 2 parenthesis x plus 1, right? Plus, after that, we got to divide the whole of this again. We now got to divide the whole of this again by x plus 1, because that's our second denominator. So I'm going to divide it by x plus 1, right? And if I'm dividing by x plus 1, then x plus 1 is going to cross out x plus 1, and we are left with x plus 3, right? So when I go back here, I'm going to multiply my numerator, which is 3. 3 parenthesis, what is left here is x plus 3, right? So I'm done with it. This was just to help us understand how we had our new numerator, right? Okay, so let's move on. Now, how do I go about it? This, I just got to use the distributive property. 2 times x and 2 times 1. 3 times x, 3 times 3, right? So moving on, I have 2 multiplied by x, I'm going to have 2x. And then I have 2 multiplied by 1, I have 2, plus, now I have 3 multiplied by x. I have 3 multiplied by x, I'm going to have 3x. Then I have 3 multiplied by 3, is going to give us what? 9. Right? Now, when we look at the denominator, we now have to multiply these two. So first of all, I'm going to multiply x by the whole of x plus 1. So I have x parenthesis x plus 1, right? Sorry. Then after that, I multiply the 3 2 by x plus 1. So it's going to be plus 3 parenthesis x plus 1. Then after that, we use the distributive property, just as we did for the numerator. So I have x multiplied by x, x multiplied by 1. 3 multiplied by x, 3 multiplied by 1, right? Just as we did for the numerator, we do the same thing for the what? The denominator. But then before we move on, let's look at the numerator. We have 2x, we want to combine like terms, plus 3x. So it's just as you're adding 2 plus 3. So I'm going to have 5x plus, I have 2 plus 9. Here I'm going to have 11, all right? All over. Now let's look at here. I got x multiplied by x is going to give me what? X squared, plus x multiplied by x is x, plus 3 multiplied by x is going to give us 3x. And then we have 3 multiplied by 1, which is going to give you what? 3. right? So when we look at the denominator, do we have like terms? Look, we have x and then 3x. So we can combine those two like terms, and that is it, we're done. So we have x plus 3x. So let's continue from this part. So I have my 5x plus 11, right? I have 5x plus 11 all over, I have my x squared plus x plus 3x is going to give us 4x plus 3. And that's it, you're done. So let's look at the next example. It's basically the same thing as the first one, just that this time the operation is rather minus. So the same thing we got to do is just to find the LCM. I have x plus 3 multiplied by x plus 1, right? So s plus 3 divided by the whole of this is going to be left with s plus 1, because s plus 3 is going to cross out s plus 3, and it's going to be left with what? S plus 1. So I multiply 2 multiplied by x plus 1 minus s plus 1 divided by the whole of this will be left with what? S plus 3. So I have 3 parentheses x plus 3, right? Now let's continue. We just have to use the same idea of the distributive property. X times 3 times x, 2 times 1. 3 times x, 3 times 3, right? So let's move on. We have 2 multiplied by x. I'm going to have 2x plus 2 times 1. I have 2 minus 3 times x is going to give us 3x. And then negative 3 multiplied by positive 3 is going to give you minus 9. Then after that, we got to multiply the whole of this by that, just as we did for the first example. I have x parenthesis x plus 1, right? Then after that, I just got to multiply the same idea, just as we did for the first one. We now take plus 3 parenthesis x plus 1, right? After that, we use the idea of the distributive property just as we did for the first example. X multiplied by x, x multiplied by 1, 3 times x, 3 times 1. But remember, the numerator, now we have 2x minus 3x. So it's just like 2 minus 3, right? So we're going to have negative x. Now we have 3 minus 9 is going to give you minus 7. Right? All over, we have x multiplied by x is going to give us x squared. Then x multiplied by 1, we have x. Now we have 3 multiplied by x, give me 3x. Then I have 3 multiplied by 1 is going to give me what? 3. Right? So we're moving on. We just got to look at the denominator if we have like terms that we can easily add or subtract. So I have my minus x minus 7 as our numerator all over. Now we have x plus 3x. So it's going to give me x squared plus 4x plus 3. And that's done. We're done. It's just a simplify. So let's look at the third example. If I have 1 over 2 and I'm multiplying by, if I'm multiplying that by 2 over 3, I just have to multiply straight the numerator multiplied by the numerator. So it's just like 1 multiplied by 2 is going to give me 2. And then 2 multiplied by 3, you have 6. So then you can go ahead and simplify to get 1 over 3. So here we're going to do the same thing. 2 multiplied by 3 is going to give me 6. Then we have x plus 3 multiplied by x plus 1. So here we have x plus 3 multiplied by x plus 1. The parentheses, we're going to use the parentheses to help us know that we're multiplying. So now we're going to pick x multiplied by x plus 1. So now I have 6 all over x parentheses x plus 1 plus 3 parentheses x plus 1, right? So here, remember we just use the distributive property to make it easy. X multiplied by x, x times 1. 3 multiplied by x, three multiplied by x, and then 3 multiplied by 1, right? Just as we did for the first few examples. 3 multiplied by 1, right? So let's continue. So now I have 6. X multiplied by x, I have x squared, plus x times 1, I have x, plus 3 times x, I have 3x, and then 3 times 1, I have 3, right? So let me continue from here. 6 all over. We can now combine this. Basically, the same thing repeats itself. X squared plus 4x plus 3, and you're done. All right, so let's look at the next example. Here, we're dealing with division. If I have 1 over 2 divided by, say, 2 over 3, right? Here we use the idea of keep, change, and flip. Keep the first fraction, change the division to multiplication, and flip this, right? So now the denominator becomes the numerator. So you're going to have 3 over 2. You just flip it, right? And now you use the same idea as we did for number 3, because we know we just multiply. So we now have 3. So 1 multiplied by 3 is going to give you 3. And 2 multiplied by 2 is going to give you 4. So we use the same idea here. We keep x divided by x plus 3. We change the division, right? We just change the division to multiplication. And then we flip this. It's now going to have x plus 1 as our numerator, and the 3 down. So we just multiply numerator. So now we have 2 multiplied by x plus 1. And then we have 3 parentheses x plus 3. Right? So we just use the distributive property. 2 multiplied by x is going to give me, I just got to multiply 2 multiplied by x. I have 2x. And 2 multiplied by 1 is going to give me 2. Then after that, you do the same thing for the numerator as well. Just use distribute. I have 2. And then I have 3 times x is going to give me 3x. Plus 3 times 3 is going to give you 9. And you're done with that. Right. So let me know if you have any other question. All right. So this is an exercise for you to just take your time and do it. And then you email it to me. It's basically the same examples as we did, but in different forms. All right. So let's move on to the next one. We have linear inequalities in one variable. Remember, we spoke about what is an inequality. We've just looked at expressions, we looked at equations, but this time we just want to quickly look at what is an inequality. An inequality is a statement that uses one of the following phrases. If you see less than, as I earlier on mentioned, if you see greater than, not equal to, less than or equal to, or greater than or equal to, then it's an inequality. For instance, if I have 2x plus 5 less than x minus 3, then this is an inequality. Right. But supposing it was 2x plus 5 equal to x minus 3, then this is an equation because of the equal sign. We just want to see how to solve them. We solve them just as we do in equation. Then after that, we graph it. So it says, solving and graphing linear inequalities in one variable. Find the truth set of the following linear inequalities and represent your answer on a number line, right? So let's look at the first example. I have 1 minus 6x less than or equal to 13 minus 3x. And I have to solve this, and then after that, graph it on a number line. You solve it as you would have solved it if it were to be an equation, right? So the first thing I need to do is just to combine like terms, or to make sure we have the x's, the terms with x on one side of the inequality, and then the constants on one side of the, on the other side of the inequality. So whatever I have here, right, I remember that we used to say it crosses. Like if I want to make sure I want to get rid of the negative 3s, it says when you move it across the inequality sign, it doesn't really move. It's just like you're using a beam balance. So if I want to get rid of the negative 3s, all what I need to do is to add 3x here, right? Since it's an inequality, whatever you do on the right hand side, you do the same thing on the left hand side. So since I added 3x, I got to add 3x on this side. And that is what we call the addition property of inequality. If it's an equation, you say addition property of what? Equation. Now that you've added, we have negative 3s plus 3s. You see that it's going to cross out, right? So I just have to bring my 1 down, right? So I just brought the 1, I have 1. Then we have negative 6s plus 3s is going to give you minus 3x. So I just have to bring this 2 down and bring my 13 down. So I have my less than or equal to sign and then 13. Right, so I want to now get rid of the 1, 2, right? If it's positive, you do the opposite. If it's negative, you do the opposite, right? So here, if I want to get rid of the 1, I just have to subtract 1 on both sides and then subtract 1 on this side as well, right? I just have to subtract 1 on both sides. So subtract 1 on both sides. And when you're subtracting, you see subtracting property of an inequality, right? So now I have 1 minus 1, then it crosses out. So I bring my negative 3x down. I have minus 3x and bring my symbol down. And I have 13 minus 1, I have 12, right? So this time, if I want to get the x by itself, right? I want to get the x by itself. If I want to get the x by itself, then I have to just divide this by the coefficient. Just by the coefficient. So I have divided by negative 3. I divide by negative 3. Right. So now I know negative 3 is going to cross out negative 3. So I have my x by itself. So now I have x. And when I divide 12 by negative 3, I'm going to have negative 4. Now, let's pay attention here. Immediately you divide by a negative number, then this symbol, it flips. If it's less than or equal to, then it's going to be what? Greater than or equal to. You're done. It shows you that the solutions for the inequality is x greater than or equal to negative 4. So we now have to go ahead and graph. So I'll go ahead and draw my number line. And I'm looking for more of negative numbers. So let me start. I have 0, 1, 2, 3. I don't need more of the positive. So let me say 1, 2, 3, 4, and say 5. So I have 1, negative 1, negative 2, negative 3, negative 4, and negative 5. Right, we say our x is greater than or equal to negative 4. So I have to start, I go to negative 4, then I make my little circle on negative 4, right? But I know that it says greater than. When I'm here, the numbers that are greater than negative 4 are on the right. So from here, I just move straight. They're supposed to be on the right, so all the way up. All these numbers are greater than or equal to. And since it's greater than or equal in the circle, make it a closed circle, right? Because of the bar under it, right? Because of the bar under it, because of this bar, if it to be there, then you leave it as open. Right, because it's closed, it means the negative 4 is part of the solution. All right. Then after that, I move to my second example. It says 2 parenthesis x minus 2 is greater than or equal to 5 parenthesis x plus 1. So here we just use the distributive property. I'm going to have 2 times x and then 2 times 2. 5 times x and then 5 times 1. Right, so 2 multiplied by x, I have 2x minus 2 times 2, I have 4. Greater than or equal to 5x plus 5. So I now do the idea of getting all the like terms on one side. So if I want to get rid of 5, also 5s, I have to subtract. Because it's positive, I do the opposite. Minus, subtract 5s on both sides. Because I want to make sure that I have all the x's on one side. And when I'm subtracting, we call it subtraction property of an inequality. Right? So now you realize that 5x is going to cross at 5x. Right? So I have 2x minus 5x. That one's going to give me what? Negative 3x. So I bring my negative 4 down. The whole of this, bring it down. Minus 4 greater than, now we only have positive 5 here. So I have 5. Now I want to get rid of the negative 4. So I do the opposite. If it's negative, you do the opposite. It's going to be add 4 on both sides. Right? And when you're adding, we see addition property of inequalities, right? So now I just have to bring my negative 3 down because there's nothing, we didn't do anything to it. So I just bring this down. I have minus 3x. But let's look here. We have negative 4 plus 4. So this is going to cross out that, right? So I'm left with greater than or equal to 5 plus 4. I have 9, right? But then I want to get x by itself. This is what we now have currently. If I want to get x by itself, then I've got to divide it by the coefficient. Whatever is in front of it, that's the coefficient minus 3. Then I divide this 2 by a negative 3, right? So automatically, negative 3 is going to cross out negative 3. So I have my x by itself now. I have my x. And then 9 divided by negative 3 is also going to give us what? Negative 3. And what did we say? We say anytime you divide them by a negative, this symbol flips. It was greater than or equal to, but this time it's going to be what? Less than or equal to. You're done. It tells you that the solutions or the answers are x less than or equal to negative 3. It means negative 3 too can also be a solution. So we have to now go ahead and now we just go ahead and graph it. Okay. I think this is better, right? Okay. So now I want negative 3. So I start from here 0, 1. I have 2. I have 3. Negative 1. Negative 2. Negative 3. Negative 4. I don't need much of it. So here we say our answer is less than, but we always start from the solution. So it's less than. So I go on to my negative 3. I make my circle. And we say it's less. When I'm here, all the numbers, and we say it's less. But then it's less than or equal to. Since it's less than or equal to, then I got to shade this. Right? If this bar is not under it, then you leave it open. But if the bar is under it, close it, shade it. Right? So let's look at, and that's it. Let's look at number. We have 1 over 3 multiplied by x plus 2 greater than 1 over 4 multiplied by x plus 1, right? To make it easy, you have to find the LCM, right? And the LCM, you just have to multiply the two denominators. That is 3 multiplied by 4, which is going to give us 12. So now I multiply the whole of the left-hand side or the right-hand side. I multiply that by 12. And after that, I go to the left-hand side and multiply this 2 by 12. So I multiply by 12. Right. So after that, we just have to simply ask ourselves, how many times can 3 divide 12? You realize that it's going to be what? 4. So that after I say 4 multiplied by 1 is going to give me 4. And then I'll write the whole of that. Parenthesis x plus 2. Greater than 4 divided by 12. So it's like 4 is going to cross out 12. 3. So 3 multiplied by 1. I have 3. Parenthesis x plus 1. Right. So after that, I just use my distributive property. 4 multiplied by x. I have 4x. And then I have 4 multiplied by 2. I have 8. Greater than 3 multiplied by x. I have 3x. And then I say plus 3 multiplied by 1. That is 3. Now, I want to make sure I get the terms that are alike on one side of the inequality and those that are not alike to on one other side, that are the constants. So if I want to get rid of the positive 3s, I subtract 3s on both sides. And when you're subtracting, that is the subtraction property of an inequality. That's SPOI. Right? So here, you do realize that 3x minus 3x is going to cross out. So now I have 4x minus 3x. Right? 4x minus 3x is going to give me x plus 8 greater than 3. Right? So if I want to get x by itself, then I have to subtract, because this is positive 8. So I just have to subtract 8 on both sides. So I have to just subtract 8. I subtract 8 on this side, and I subtract 8, right? So 8 is going to cross out 8. So I have my x by itself now, right? So now I have my x greater than 3 minus 8. I have negative 5. And that's it, I'm done. I have my solution to be x greater than negative 5. So I just have to go here, draw my number line, right? Okay, and I'm looking for negative 5. So let me go here, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Right, I have 1, 2, and 3. Right. And we say x is greater than. So I have to always start on the solution. So I have negative 5. And we say x is greater than. When I'm here, the numbers to the right hand side are all greater than negative 5. So I move all the way here. Right? And this is going to be shaded or not. It's not going to be shaded because it's not greater than or equal to. If there was supposed to be a bar, supposing we had a bar under it, then you will have shaded. It means the negative 5 is not part of the solution. All right, so thank you so much for taking your time to watch this video. And this is an exercise for you to do. I think this is one of them is a past question from the last 2 years or so. So kindly take your time, do it, and email it to me. Thank you so much, guys. Bye-bye. See you in the next lesson.